Dear students, welcome to the video lecture of Object-Oriented Design Philosophy and as well as designing the classes, and we are going to discuss about the visibility of the class. These are the three main agenda in this presentation. So we are going to start from the Object-Oriented Design Philosophy. The great benefit of Object-Oriented approach is that the classes organize the related properties into units that stand on their own. The class organizes related properties into a unit that stand on their own. Important activity in designing a classes is coming up with a set of classes that work together to provide the functionality you desire. Important activity in designing a classes is coming up with a set of classes, a group of classes that work together to provide the functionality as per your desire. Many object-oriented languages such as Smalltalk, C++, and Power Builder provide the built-in class libraries to reuse rather than creating from the new. Reusability is a very important concept that is supported by the all the languages. Consider the modern languages, the recently introduced languages, and as well as the old languages like Smalltalk, C++, Power Builder provide the built-in class libraries to reuse rather than creating from the new. Applying the design axioms and carefully designed classes can have a synergic effect not only on the current system but on the future evaluation. So UML object constraint language. So object constraint language. Constraint means some condition. So what we are able to create some condition by using a UML. That's why it's known as a UML object constraint language. The rules and semantics of the UML are expressed in English in the form of an object constraint language, OCL, object constraint language. Many UML modeling construct require expression. For example, expression of types, Boolean values, and numbers. Expressions are started as a string in the object constraint language. Expressions are started as a string in the object constraint language. The syntax for the some common navigation expressions are shown here. Item dot select. First expression item dot selector. Select is a name of an attribute of the item. The result is the value of the attribute. That means that a value will be assigned to or extracted from the attribute. For example, John dot age. So John is an item. Age is a selector. That means attribute. Age is an attribute of the object John. John.age represents the value of the attribute. The next one is set select and a Boolean expression. That means that the Boolean expression is written in terms of the object within the set. The Boolean expression is written in terms of the object within the set. The result is a subset of object in a set for which the Boolean expressions are true. For example, company.employee salary greater than 3,000. This represents the employee with salaries over 3,000. Okay, from the set it will select the subset. Okay, from all the employees it will select the subset where the employees who drawn salary more than 30,000. Item.selector qualifier value. The selector indicates the qualified association of the qualified item. The result is that the related object selected by the qualifier. For example, indexing is a form of qualification. John dot phone 2, assuming that John has several phones. Okay, actually the phone 2 means the phone number stored in the index position 2 will be extracted. So these are three object constraint language. We are having a item dot selector. Item dot means object and attribute. Set comma select Boolean expression. It will select a subset of the given set based on the Boolean expression. Item dot select qualifier value. So based on the qualifier value, the value will get extracted. Design the classes. The process. Apply the design axioms. Apply the design axioms to design the classes. Their attributes, methods, associations, structures, and protocol, which we discussed already. Refine and complete the static UML class diagram, object model by adding the detail to the diagram. Refine the attributes. Design the methods and protocols by utilizing a UML attribute diagram to represent the methods algorithm. Refine the association between the classes if required. Define the class hierarchy, design with inheritance if required. Iterate and refine. This is the designing the steps in the designing the class process. Class visibility. Now we are going to discuss about an important aspect. The class visibility means actually how the attributes and methods of the class will be accessed. What kind of permission it is giving. So designing a well-defined public, private, and protected protocols are very important in defining class visibility. In designing a methods or attribute of a class, you are confronted with the two problems. One is the protocol or interface to the class operation and its visibility, and other is how it is implemented. One is the protocol or interface of the class operation and its visibility, and other is how to implement how it is implemented. The class protocol are messages that class understand. Class protocol are messages that class understand. On the other hand, it can be hidden from the other objects. Private protocol is make the attributes and methods are hidden from the other objects and made available to the other object. Public protocol which made available to the other object. Hence, public protocol define the functionality and external message of the object. Private protocol define the implementation of the object. See here, the diagram is given. Public protocol can be accessed from anywhere. Protected protocol only accessed from those subclasses which inherit the particular class. Private protocol, actually, private is an internal protocol. Okay, those methods and attribute class, the private can be accessed by the other methods of the same class only. So, private protocol visibility of the class. It include messages that normally should not be sent from the other objects. It is accessible only to the operation of the class. In private protocol, only the class itself can be used the method. Second is public protocol visibility. It defines the certain behavior of the class as a citizen in a population or an important information of the user as well as the future descendants. So it is accessible to all the classes. All the methods and attribute class public can be accessed by all the classes. If the methods and attributes can be used by the class itself or its subclass, a protected protocol can be used. Methods or attributes can be used by the class itself or a subclass. A protected protocol can be used. So protected protocol visibility, the subclasses, the subclass that can use the method in addition to the class itself. Okay, the subclass can be accessed the methods and attributes which are declared as a protected protocol. The problem of encapsulation leakage is a very important problem. It occurs when the detail about the class internal implementation are disclosed to the interface. As more internal detail become visible, the flexibility of making changes in future decreases. Public and protected protocol can be accessed the private attribute and can reveal an important aspect of your implementation. If anyone use this function and you change their location, the type of attribute or a protocol of the method, this could be make the client application very inoperable. When you declare as a public protected, protected method that can be accessed the private attribute, that means that can reveal the important aspect of implementation. When encapsulation leakage means that your secrecy is leaked outside, then it will create a lot of problem. Design interface between the superclass and the subclass is just a carefully design the interface class interface to the clients. There is a contract between the superclass and subclass. If this interface is not designed properly, it can lead to the violation of the encapsulation of the superclass. If the class superclass subclass interface is not properly designed, it means that the subclass can access everything from the superclass. That means it violates the encapsulation of the superclass. The protected portion of the class interface can be accessed only by the subclass, not the private portion. Other important factors include which function might or might not be overridden and how they must behave. It is also critical to consider the relationship among the methods. Some method might need to be overridden in group to preserve the class semantics. Private and unprotected protocol layers. So that is internal layer. Apply the design axioms and corollaries, especially corollary 1, uncoupled the design with the less information content to decide what should be private, what attribute, instance variable, or what method should declared as a private. Remember that highly cohesive object can improve the coupling. If the object is contain the self-sufficient or a lot of what to say an internal content, internal connection, they need very less information to be shared from the outside. So highly cohesive object can improve the coupling because only minimal amount of essential information need to be passed between the object. Next one is public protocol layer. Let's say external protocol. Item in this layer define the functionality of the object. Here are some things to keep in mind when designing the class protocol. Good design allows for polymorphism. Good design allows for polymorphism. Polymorphism means that actually a function which behave differently in different situations is known as a polymorphism. Not all the protocols should be public. Again, apply the design axioms and corollaries. Following the key questions must be answered. What are the class interface and protocols? What public external protocol will be used, and what external message must the system understand? What private and protocol internal protocol will be used, and what internal message or method message or messages from the subclass must the system handled. Then actually we have to discuss about the attributes. Attributes identified in object-oriented analysis must be refined with the ION implementation during this phase. Analysis phase, the name of the attributes was sufficient. However, in the design phase, detailed information must be needed. The main goal of the activity is to refining the existing attribute or add the attribute that can elevate the system into implementation. So we will discuss more about the forthcoming video lecture about this. Okay, thanks for watching the video.